Guys, now we're officially on the AWS Lambda begin page. Cool. Now, this page right here helps us really understand how Lambda works, visually and practically. Yeah, this is the brain of Lambda. It literally explains how everything runs behind the scenes. Okay, first things first, Lambda supports multiple programming environments: .NET, Java, Node.js, and if you've got something else, no problem. You can roll with your custom runtime. But today, I'm going to show you something cool: how Lambda works without worrying about any runtime setup. This is just a demonstration, not the real execution, okay? All right, let's click the Run button. Boom, Lambda starts running. And you see, it printed, "Hello from Lambda." That's the magic moment. Our Lambda just came to life. Now, let's dig deeper. How does this actually run? Lambda runs on an event-driven architecture. That means it doesn't just sit around all day. Nope, it wakes up only when something triggers it. Think of it like this. Lambda is that lazy genius friend. Doesn't move until you call their name, then suddenly becomes a superhero. So, when a service, like a stream or API gateway, sends an event, Lambda jumps into action. It says, "Oh, someone needs me," and starts the whole process. According to this figure, here's what happens. A streaming service sends an event. Lambda goes, "All right, let's go." Then it uses something called Firecracker, a lightweight virtualization service. Don't get scared by the name. It's not a literal firecracker, okay? Firecracker simply creates a tiny, super fast container. That container then downloads your code, all the dependencies, sets up the runtime, and finally executes your code. We call this a cold start because everything is cold, freshly loaded from scratch. Cold start. So cold, so fresh, so powerful. But wait, if another event comes right after that, Lambda says, "Hold up, I already have a warm container. Let's reuse it." That's called a warm start, much faster. However, if there's no event for 5 to 15 minutes, Lambda goes to sleep again and shuts down the container to save resources. That's the Lambda lifecycle, my friends. Okay, guys, now that we know how Lambda works behind the scenes, it's time to get our hands dirty and create a real Lambda function. Rock and roll. So let's jump into the AWS console and make some serverless magic happen. All right, I'm on the AWS console panel now. You can see I've got some recently visited services here. Lambda, API Gateway, DynamoDB, all my best friends. But hey, if you don't see Lambda in your console, don't panic. It's not gone on vacation. Just type Lambda in the search bar right up here, like this. Boom, there it is. Click that and you're inside the Lambda service. Since I've already created a few Lambda functions, it takes me straight to my list of functions. But if this is your first time, you'll see the begin page instead. Don't worry, same destination, different doors. Now let's click the Create Function button. This page pops up where we can choose how to create it from scratch, use a blueprint, or even a container image. For this demo, I'm keeping it simple. Author from scratch. Now here's a text field for our function name. Let's call this one Rock Lambda Tutorial, because it's gonna rock. Next, we have to choose our runtime environment. I'll pick Node.js for this demo, but you can choose .NET, Java, Python, or even Ruby if you're feeling fancy. No need to change the architecture or other settings right now. Just scroll down and hit Create Function. All right, it's creating. Just give it a moment. Come on, AWS, do your thing. And there it is. Our brand new Lambda function is ready. Now look at this. The Lambda console looks a lot like Visual Studio Code, right? You've got a file explorer, an editor, and all the magic happens here. The main file is index.mjs, and inside it, there's our function code. It's a simple hello from Lambda message that returns a JSON response. Pretty neat for a few lines of code, huh? Now let's test it out. I'm switching to the Test tab. Here we can create a new event, but remember, Lambda always runs based on an event trigger, so when we press the Test button, it's just simulating that trigger. Okay, let's hit Test. Boom! Look at that! The Lambda executed perfectly, returning our Hello from Lambda message. You can also see details like duration, memory used, and cold start time right below. AWS gives you all the performance stats you need to brag about your efficiency later. And here's something cool. Lambda automatically connects to CloudWatch logs, so you can monitor every single execution, invocations, errors, durations, all in real-time charts. So if your function crashes, well, at least you'll know why. You can even tweak the general configuration here. Increase your timeout so your Lambda doesn't rage quit too soon. Give it more memory, aka more RAM power, or add some ephemeral storage if it needs a bigger playground. All right, back to the code editor. Let's make this function a bit more personal. I'll change the message from Hello from Lambda to Hello from Rock Team. Now I'll hit deploy, and deployed successfully! Nice! Our function is live and rockin'. But wait, how do we actually execute this from a browser? Easy. Let's create a function URL. Go to the Configuration tab, then click on Function URL in the sidebar. Now hit Create Function URL. Select Auth type as None, since this is just a demo. Don't try this in production, okay? Click Save, and boom! We've got our own function URL. This URL is like your Lambda's personal stage. Anyone who visits it triggers your function instantly. Let's open it in a new tab. And there it is! Hello from Rock Team, displayed proudly on the screen. Ladies and gentlemen, your first Lambda function is officially live. You created it, deployed it, and called it from the AWS console.
Okay, now we're going to set up our local environment. We need to install AWS CLI. Why do we need it? Because this is what lets our local machine talk directly to AWS services. Without it, your computer is like, "Hey, AWS!" And AWS is like, "Who are you again?" So let's install it. Open your browser, I'm using Google Chrome, and just type AWS CLI install. Yeah, not install AWS chicken wings, okay? Stay focused. Now you can see installation options for Windows, Mac OS, and Linux. I'm going to select Windows. Then it shows you MSI installers, 64-bit or 32-bit. Just pick yours and download. Run it, click Next, Next, Finish, and that's it. Simple, right? You don't even need a coffee break for this one. Once the installation is done, open your command prompt or terminal and type AWS-version. If you see something like AWS-CLI/1.x.x, nice! That means AWS CLI is successfully installed and ready to go. Now, we need to connect our AWS CLI to our AWS account, because right now AWS CLI is installed, but it doesn't know who you are. You could be anyone, maybe even a hacker. So we'll authenticate properly by creating a new IAM user. Go to your AWS console, search IAM, that's Identity and Access Management. This service handles all the authentication and authorization. Basically, it's the security guard of AWS. Now, click Users on the left, and then click the Create User button. I'll name this one Rock App User, because, well, it rocks. Then, under Permissions, select Attach Policy Directly, and choose Administrator Access Policy for now. This gives our CLI full control, but remember, in production, always use minimal permissions. Click Next, then Create User. Now, click your new user from the list. Go to the Security Credentials tab, scroll down until you see Create Access Key, and click it. Now, you'll see different use cases: CLI, SDK, third-party apps, etc. Select the Command Line Interface, CLI option, tick the I understand the checkbox. Yes, we understand everything. Then click Next, and finally, Create Access Key. Boom! You'll see your Access Key ID and Secret Access Key. Important, do not lose that secret key. If you lose it, you can't get it back. AWS will just say, sorry buddy, make a new one. Now open your terminal again and type AWS configure. Then enter Access Key ID, Secret Access Key, default region, for example, US-East-1, and default output format. You can leave this blank or type JSON. And that's it. Your local machine is now officially connected to AWS. You're basically a certified AWS agent now. Mission possible! Okay, we need to install Amazon Lambda tools for .NET. Open your browser again and search Amazon Lambda Tools.net. You'll see a NuGet page. Click it. There you'll find the install command, .NET tool install-g amazon.lambda.tools. Copy that, paste it into your terminal, and run it. Done. Now you've got all the tools you need to deploy Lambda functions straight from your machine to AWS.
Okay guys, now we're moving to the real deal, deploying a .NET API on AWS Lambda. Let's go! So, first things first, I'm going to create a new project, but not a boring empty one. No. We're using a special AWS Lambda template that came from the AWS Lambda Tools package. Yeah, we already downloaded that one like pros. Okay, so now look at my screen. You can see I'm using Rider IDE. You can use Visual Studio too if you're feeling fancy, but me, I'm loyal to Rider today. So here, in the custom template section, look at this beauty. A whole bunch of AWS templates. So many templates, it looks like AWS had a buffet here. Now, for this demo, I'll pick Lambda ASP Net Core Minimal API Template. Why? Because it's lightweight and perfect for showing off. I'll name my project Lambda Test First. Very creative name, I know. And hit that Create button. Click. Boom! Project created. Now, check this out. This template.yaml file. This file is like the blueprint. It tells AWS how to build the entire infrastructure. CloudFormation uses this to magically create all your stuff without you doing anything manually. It's like saying, hey AWS, build me a house. And AWS goes, say less. But today, I don't need this file. So, delete, gone. All right, next. We've got another file here, AWS Lambda Tools Defaults.json. This one's important. This is where we define our function name, runtime, memory, timeout, handler, everything. So let's set it up. Function name, same as our project name. Timeout, 30 seconds, because we're fast but not flash. Memory size, 256 megabytes, enough to flex, not too much to pay. Runtime, .NET 8, because we are living in the future. Function URL enabled? True, because we like URLs, right? Okay, good. Now check the controller. It's a calculator API. Simple stuff. Add, subtract, multiply, divide. Basically the only math I still remember from school. Now, let's go to program.cs. This is where the magic begins. Here, you'll see something new. Add AWS Lambda hosting. That's what makes your API run on Lambda instead of your local machine. If you don't have the package yet, don't panic. Just install amazon.lambda.asp.NET Server Hosting, okay? Do it! Laughs. Now, one more thing. I'm going to switch my API from REST to HTTP. Why? Because REST is a bit picky about URLs and HTTP is just chill. All right, now, before I run this project, I'm going to add Swagger because every cool dev adds Swagger before showing off a demo. Add package, configure service, enable Swagger, done. Boom, Swagger, baby! Laughs. Now, let's run this locally. You can see our API is working. We've got endpoints for add, subtract, multiply, divide. Let's test them. Yeah, all good. Okay, deep breath, because now we're going live. Time to deploy this API to AWS Lambda. Step 1, open your terminal. Make sure you're inside the same folder as your .cs proj file. Then type this magic spell, .NET Lambda deploy function. Now, it'll ask for a role. A role is like AWS's security badge. It tells Lambda what it's allowed to do. I'm not using an old role. No. We're making a fresh, new one. So I choose the option to create a new role. Then it asks for a role name. Let's call it Rock Lambda Tutorial because we're rocking this demo. Now, AWS says, hey, what policy do you want? We'll attach the Lambda basic execution policy because we don't want to burn down the cloud yet. Now, hit enter. Wait a few seconds, tapping sound voice, and, drumroll please, deploy successful! AWS gives us a function URL. This is our API's gateway to fame. Now, open Postman. Paste that function URL, hit send, and boom, response received. Hello from Lambda. See? It took a couple of seconds because this is the cold start. Lambda just woke up, stretched, downloaded all dependencies, and brewed a coffee before responding. Now hit it again. Bam, milliseconds. That's the warm start because our container is already awake. It's sipping that second coffee now. So remember, cold start is waking up, warm start is already running. Now, after a few minutes, if there are no new requests, Lambda just says, all right, I'm out, and shuts down that container. Now, let's go to the AWS console and check. Look here, under Lambda services. You'll see our Lambda test first function right there. And guess what? We didn't even touch the console for deployment. We did everything from the terminal, like true command line ninjas. So now you know how to create, configure, and deploy your .NET API to AWS Lambda.
All right, everyone. Now it's showtime. Okay, now I'm going to show you how to deploy a fully serverless application on the AWS environment using .NET, AWS Lambda, API Gateway, DynamoDB, and S3 Bucket. And trust me, this project is amazing. Like, save your wallet and your sanity amazing. Because using this architecture, we can save a lot of money. A lot of money, okay? So, let's dive in. Okay, now you can see my screen. Here's the architecture I'm using for this project. We've got a front-end project and a back-end API project. The back-end API, that's deployed on AWS Lambda. The front-end, built with React.js, deployed on S3 Bucket. Now first, I'll explain the overall architecture, then I'll show you a simple demo of my application. This isn't a massive production app, okay? It's just a cute little demo for our team project. I call it the Rock Project Call Center. Call Center. So this app, it's like a small call center tool. Not all the features are there, just enough for this demo. Okay, now you can see my screen. This is the call center app. Let's walk through it slowly. I'm selecting a brand. Let's pick Tesco. Then I choose an agent. Yeah, let's go with agent.
Next, I add the traveler details. Then continue the process. Select trip type, single trip, or annual trip. I'm selecting single trip. Then choose country, trip start date, end date, and finally, boom, I hit generate quote. That button triggers an API endpoint behind the scenes. That endpoint goes straight to my .NET API deployed on AWS Lambda. That API saves all the data to DynamoDB. Now, let's peek at the .NET project. Here's my backend, a simple .NET API project. Nothing fancy, just the essentials. Controllers, services, DTOs, models, nice, clean structure. If you already have your .NET API project, you can deploy it too, easily. But before that, remember this very important file, AWS Lambda tools.defaults.json. That file is your Lambda configuration file, okay? Inside, you set the function runtime, timeout, handler function name, and all that AWS magic stuff. Don't forget that file, or Lambda will forget you. Okay, now in my project, I've got two endpoints, /create_quote and /getCountries. And here's something important. This project is not doing any in-memory tasks, which makes it perfect for Lambda deployment. Okay, check this out. You can see the DTOs folder, models, and services. Everything's separated like a good student who labels all their notebooks. All right, let's talk database. We're using DynamoDB, baby. Two tables, quote table and country table. In the code, we define our models like this. DynamoDB table, quote. You also define the primary key. DynamoDB hash key is ID. And the rest are DynamoDB property attributes. Nice and clean. So yeah, DynamoDB is basically a big fancy JSON storage in the cloud, but on steroids. Now, in the program.cs, I register my DynamoDB service and AWS Lambda hosting service. And a small reminder, if you're using REST API style in Lambda, you can't use Lambda's direct URL. You'll need to use HTTP API setup instead. I'll explain the REST versus HTTPI difference later, but just remember that. Okay, now back to the architecture diagram again. You can see front end on S3, back end on Lambda, database on DynamoDB, and the traffic routing and auth handled by API Gateway. So when a user opens our website, they load it from S3 bucket. Then when they hit generate quote, it triggers the API Gateway, which invokes Lambda, which saves data to DynamoDB and returns a response. Boom! Fully serverless workflow. Okay, now I'll show you what packages I used in the .NET API project. Number one, Amazon.lambda.asp.net core.hosting. Number two, AWS SDK.DynamoDB v2. And number three, Amazon.extensions.net core.setup. And don't forget to add this inside your cproj file. AWS project type equals Lambda. Otherwise, Lambda will pretend your project doesn't exist. Okay, now let's deploy it. In Visual Studio, I open the terminal and run .NET Lambda deploy function. Lambda will ask for a role. You can use an existing role or create a new one. I created a new role called RockCC Backend Role. Then attach AWS Lambda Basic Execution Role policy. And ta-da! Project deployed successfully. Okay, one important thing. When your Lambda needs to access DynamoDB, make sure your IAM role has permissions. Go to IAM, Roles, open your Lambda's role, click Attach Policies, then add Amazon DynamoDB Full Access. Save, and now Lambda can save and read data. Everything is connected. Okay, let's confirm it. Open AWS Console, Lambda, and there it is, our shiny new Lambda function. Now to connect it with API Gateway. I open API Gateway in the AWS console, click Create API, choose REST API. HTTP APIs are cheaper, lighter, faster, but REST APIs give you more control and drama. So here, I pick REST API, click Build, give it a name like RockCC API, and click Create API. Then, create a resource. I tick the proxy resource option. That allows flexible paths for any endpoint variable. Then click Create Resource. Next, I integrate Lambda function, choose the Lambda function we just deployed, tick Lambda proxy integration, and in the body pass-through, choose when no template matches. Save it. Done. API Gateway and Lambda, now they're best friends forever. Okay, now we deploy the API and create a stage. Let's call it Dev. Click Deploy. Boom! Now you get an invoke URL. That's your API URL to call from Postman or frontend. Let's test it. In Postman, I hit the /countries endpoint, wait for it, and yes, it returns the country list. Lambda, API Gateway, and DynamoDB are working beautifully together. Now, let's deploy the front end. Go to AWS Console, S3, Create Bucket. Bucket names must be unique globally, like RockCC Demo Front End. Untick Block All Public Access because we're hosting a website. Create the bucket. Now open it, upload your React build artifacts, the build folder contents, index.html, assets, etc. Then go to Properties, scroll down to Static Website Hosting. Click Edit, enable it, set index.html as both index and error document. Save. Next, set the bucket policy to make it public for read access. Action S3 get object, allow, principal star. Save the policy. Now scroll down again, click the bucket website endpoint link, and boom, your React app is live. Now let's do a little end-to-end victory dance. User opens our site from S3 bucket, creates a quote, that request goes to API Gateway, triggers Lambda, Lambda saves data to DynamoDB, returns a response, user sees success. Fully serverless, baby.